Hello friends, welcome back to the session. So in this video, we will be covering the question number 17 to question number 20 from the exercise 1.1 of the topic complex numbers. Okay. So previous questions all are solved in the previous videos for obvious. So question number. So if you have not seen those videos, please go through that and check out that videos. Okay. So let's see the question number 17. What it says: if a is equals to minus 1 plus root of 3i upon 2 comma b is equals to minus 1 minus root 3i upon 2, and show that a square equals to b and b square equals to a. Okay, so if these are the values of a and b, then we have to show that a square equals to b and b square equals to a. So let's try to prove first one, a square equals to b. So this is our a, so let's take the a square. So it will be equals to minus 1 plus root 3i whole square divided by 2 square. So this is equals to, so a plus b whole square will be what? Minus 1 square plus 2 into minus 1 root 3i plus root 3i whole square whole divided by 2 square is 4, which is equals to minus 1 square is 1, so it is 2 minus 2 root 3i, and it's root 3 square is 3 and I square is minus 1, so it is a minus 3 upon we have 4. This is equals to minus 2 root 3i upon 4. So this is equals to what? The a square. Now if I take the minus 2 or the positive 2 common, so what I will get? So if I take 2 commons, I will be having minus 1 minus root 3i upon 4. Now this 2 cancels this 4 by 2, so this is nothing but a square equals to, let me have space here, so a square equals to what is remaining is minus 1 minus root 3i by 2, and if you see, this is nothing but our b. Okay, so this is nothing but the given b is. See, so hence proved, the first part is proved, that is a square is equals to b. Similarly, we can prove that the b square is equals to a. So let's take the b. So what is b is minus 1 minus root 3i upon 2. So let's take the b square here. So b square equals to minus 1 minus root 3i whole square upon 2. Now let me write this. Minus 1 square is 1. So it's 2, so it's 2 into 1 into, so minus minus plus, I am directly writing it. So it's a plus root 3i whole square whole divided by, we have 2 square is nothing but 4. So this is equals to 1 plus 2 root 3i. So it's root 3 is minus 3 divided by 4. So it is nothing but 1 minus 3 is minus 2 plus 2 root 3i upon 4. So if I take, what you will take now, minus 4, 2 or plus 2. Okay, let's take plus 2 common. So if I take plus 2 common, so I will be having minus 1 plus root 3i divided by 4. This cancels by 2, and this is equals to minus 1 plus root 3i by 2. This is nothing but my b square, and if you observe, this is nothing but a again. Okay, so in this way we have proved the second one also, that is b square is equals to a. Okay, it's very simple boss. देखो भाई कुछ नहीं किया, हम लोगों ने a and b दिया था, तो हम लोगों ने a square and b square उन्होंने पूछा था, हम लोगों ने निकाल दिया. It's very easy. Okay, so let's see the question number 18 then. Okay, so the topic is very simple. Just you need to understand the basic fundamental operations of the complex numbers. So let's see the question number 18. If x plus iy is equals to a plus ib, it's a cube, then we have to show that x by a plus y by b, it is equals to 4 into a square minus b square. This we have to show that. Okay, so देखो भाई क्या दिया था और क्या दिया है और क्या निकालना है, that is very important. see they are asking for x by a plus y by b. Okay, means what? Here from in this, if you see, there is no imaginary term, but in the given information there is imaginary term. So let's segregate the real part and the imaginary part. Okay, so let's see how we can do that. So x plus iy is equals to a plus ib, it's a cube, which can be written as a cube plus 3 into a into ib plus, okay, 3a square into ib plus 3 into a into ib square plus ib cube. Okay, so I have used the formula a plus b cube, which is nothing but, okay, which is nothing but 3a cube plus 3a square b plus 3ab square plus b cube. This formula I have used here. Okay, this is equals to a cube as it is plus 3i a square b plus 3a I square b square. So I square gives me -1, so let's keep that -1. So 3ab square plus this I cube we are having. So I cube is again, it's a -1, so it's a minus of I into b cube. Okay, so what is remaining then? Now separate the real part and the imaginary part. So you will be having a cube minus 3ab square, this is one part, so keep this part and this part, plus let's take I common, so here 3a square b and minus of b cube, okay, into I. So from these two I have taken the I common. Okay, so if you see, this is equals to x plus iy. Now this is my real part and this is the imaginary part. Okay, this is real and this is imaginary. So what we can do, simply you compare these two equations and you will get the value of real part is equals to real part and imaginary part is equals to imaginary part. Therefore x is equals to what? It's a cube minus 3ab square. Okay, and what is y is equals to? It is a 3a square b minus b cube. Now if I take a common here, what I will get? A in bracket a square minus 3b square. So x by a equals to what? So this is x, so x by a equals to what? It is a square minus 3b square. Similarly from this, if I take b common, so it will be 3a square minus b square. So if I take this b in the denominator, I will be getting 3a square minus b square. Is it okay? Now see here what we are getting. We have the value of x by a and y by b, and in the question they are asking the same value, x by a plus y by b. Okay, so let's add these two equations. So equation number 1 and the equation number 2. So let's add 1 and 2. So adding 1 and 2, you will be getting x by a plus y by b, it is equals to, let's add first x, 3a square b. Now let's add the second one, plus 3a square minus b square. So it's a square plus 3a square becomes 4a square, and minus 3b square minus b square becomes minus 4b square, and if I take 4 common, I will be having a square minus b square. It's very simple, boss. See, when you get the answer now, it becomes very interesting. You will enjoy this. Okay, so this is what the required answer is. In this way we can prove this. Okay, the more practice you do, the more tricks and tips you will get. Okay, so in this what I have done, just I have tried to remove this imaginary part, because in the question we have not seen any imaginary part. Okay, so that's why my approach is in this direction. Okay, so you will get the approaches once you get the more practice on this topic. So I request all of you, please try to solve all these questions on your own. Okay, after watching this video, see, just watching the video is not sufficient. ठीक है, सिर्फ क्रिकेट देख के कोई सचिन तेंदुलकर नहीं बन सकता. ठीक है, सचिन तेंदुलकर बनने के लिए प्रैक्टिस करना चाहिए. वेरी गुड. सो लेट्स सी द नेक्स्ट वन. सो प्रैक्टिस करना है आपको, बहुत सारे क्वेश्चन सॉल्व करने हैं आपको. ये तो क्वेश्चंस भाई हम लोग क्लास में सॉल्व कर रहे हैं, बट इट्स वेरी इंपॉर्टेंट दैट after watching this video you solve these all questions on your own. Okay, so the next question is, if a plus 3i upon 2 plus ib Okay, it is equals to 1 minus of I. Then we have to show that it's a 5a minus 7b, it is equals to 0. Okay, so we have to show this 5a minus 7b equals to 0. Now in the question, if you see, we again do not have any imaginary part, all is the in the real part. Okay, so and it is in terms of a and b. So let's solve this given information. Let's solve this. So let's take that as it is. So it is a plus 3i, it is equals to, I am taking this 2 plus ib in this side, so it is 1 minus I into 2 plus ib. Now if I solve this, solve means what? Open these two brackets. So 1 into 2, 1 into minus ib plus ib, so it is 1 into 2, then plus 1 into ib, then plus minus I into 2 plus minus I into ib. Okay, so after 1 I am multiplying these two. So this is equals to 2 plus ib, then we have minus 2i, then it is equals to I into I is minus 1, minus minus plus 1 plus b. Okay, so this is equals to, so if I take the common things, the real part is 2 plus b and the imaginary part is b minus 2 and I, and if I compare these two equations, what I will be getting? So real part will be equals to real part and the imaginary part will be equals to imaginary part. So I will be having a plus, sorry, not a plus, so it is a equals to 2 plus b, and the next we have is 3 is equals to b minus 2. So from the second equation, if 3 is equals to b minus 2, then what will be the value of b? B is equals to 5. Okay, if b is equals to 5, substitute in this first equation, a equals to 2 plus this b is 5, so it becomes 7, so a is 7. Okay, so once you get the value of a and b, now it's very simple. So substitute in this equation, so 5 into a is what? It is a 7, minus 7 into what is b is nothing but 5. Okay, so this is equals to 7 5s are 35 minus 35, and this is equals to, wow, it's 0. Okay, so what we have done, we have just solved whatever the information they have given. That's very important. Okay, see, it's very very simple. Do not look at any question just for the sake of looking. Okay, मतलब क्या बोलना है मुझे कि just देखना है इसलिए नहीं देखना है. Just do not look at the question for the sake of completion. Understand, try to understand the concept. Okay, well, very good. Let's see the next one now. So question number 20. So this will be the last question for this video. Question number 20. So what it says, if x plus iy equals to root of, so big root, a plus ib upon c plus id, then prove that it's x square plus y square whole square equals to a square plus b square upon c square plus d square. Okay, this is what we have to prove. Okay, चलो कोई बात नहीं, हम लोग प्रूव करेंगे इसको भी. इट्स वेरी सिंपल, जस्ट सॉल्व द गिवन इन्फॉर्मेशन. टारगेट कौन है अपना? टारगेट इसको करना है, जो भी दिया है इन्फॉर्मेशन उसको टारगेट करना है. उसके बाद वी विल गेट सम वैल्यूज एंड वी विल पुट इन दिस एंड वी विल प्रूव दिस सिंपली. Okay, so let's take the first one. So we have x plus iy, it is equals to root of a plus ib upon c plus id. Now if I take the squares on both sides, so what I will be getting, x plus iy whole square equals to a plus ib upon c plus id. Okay, it's very simple, and let's open this now. X plus iy is nothing but x square plus 2xy into I minus of, see here, now I am writing I square and y square. I square is minus 1, so it's a minus of y square. It is equals to See, the thumb rule says that we do not want any imaginary part in imaginary term, the complex number in the denominator. So let's remove this. How you remove this? Just multiply and divide by its complex conjugate. So it's a plus ib upon c plus id into c minus id upon c minus id. I am just dividing and multiplying by complex conjugate of this complex number. So this is equals to x square minus y square real part plus 2xy is the imaginary part. It is equals to, now let's see what we get. So this is 1, so it is a plus ib into c minus id, and here we have a plus b and a minus b, so it is equal to c square minus id whole square. So if I open these two brackets, I will be getting a into c minus of a di, then we have plus bci, and the last will be I into I is minus 1, so minus minus plus of b into d whole divided by, so it is equals to c square plus d square, so minus minus plus 1. Okay, so this is equals to ac plus bd, again I am taking the real part and the imaginary part separate, ac plus bd plus bc minus ad into I whole divided by c square plus d square. Okay, now if I compare these two equations, so that this is nothing but here, so this is my real part, okay, and this is my the imaginary part. So let's equate these two equations. So x square minus y square is equals to what? I will be getting the real part, so ac plus bd upon c square plus d square, it's a real part, and the imaginary part is, it is 2xy, it is equals to bc minus ad upon c square plus d square. Okay, so this is what the real part and imaginary part is. Now let's see what they have asked is, so they are asking for the value of x square plus y square equals whole square. Okay, so let's solve this. X square plus y square, no, x square plus y square equals to, so x square plus y square equals to, okay, let me have this here. So x square plus y square whole square, it is equals to what? X square uska square plus 2x square y square plus y square uska square. Okay, now this is what the expansion of, but we have these two values with us. Okay, but if you see here अभी कोई कुछ भी value अपने काम का नहीं है. So let's use the another formula of this. So this is what? This is nothing but a plus b whole square. Okay, and what is the formula? A plus b whole square is, another formula is, see, first formula is what is a square plus 2ab plus b square. This is the first formula, but I want the same formula in terms of this part and this part. So a plus b whole square is equals to what? It is a minus b whole square plus 4ab. Okay, so if you open this, you will get, see here I will give you the proof. So it is a square minus 2ab plus b square plus 4ab. Okay, so it is nothing but a square minus 2ab plus 4ab becomes 2ab, okay, plus b square. Now see here, these two formulas are same, no? So what we can write is a plus b whole square is equals to this also. So let's use that formula here. So x square plus y square whole square is equals to x square minus y square whole square plus 4 x square and y square. Okay, now this is equals to x square minus y square whole square plus 2xy whole square. Now see here, we have both the values. This is first value and this is the second value. Now let's substitute here. X square plus y square is nothing but this part. So it is ac plus bd divided by c square plus d square. So its square, little bit calculation is there. So 2xy is nothing but bc minus ad upon c square plus d square. Okay, so it's square. Okay, now let's open these two. It is okay, bit having calculations. So ac plus bd whole square, so open this. So it is a square c square plus 2ac bd plus b square d square upon, I will be writing c square plus d square whole square plus b square c square minus 2bc ad plus a square d square whole divided by again c square plus d square whole square. Okay, if you see the denominator is same, so we can easily combine these two, a square c square plus b square d square plus 2abcd. See, this part I have rearranged 2abcd. So coming to the second part, plus b square c square minus 2abcd, again I have rearranged this term, plus a square, plus a square and d square whole divided by, what is the common denominator is c square plus d square is the common iska square. Okay, now if you see, this part and this part can be cancelled out easily. So do we have anything left? So a square c square plus b square d square. So a square c square plus b square d square plus b square c square plus a square d square whole divided by c square plus d square whole square. Okay, so what we want to show, that it is nothing but a square by b square upon c square plus d square. Okay, so a square plus b square upon c square plus d square. So next what we will do, I want to remove this c square plus d square from the numerator and 1 from the denominator. So what you can do, c square, so can we have some common from these two? Yes, of course, from these two I will take common a square, so I will be remaining with c square plus d square. Then again you take the common from these two, that is a b square plus b square, in bracket we have d square plus c square. In the denominator you will be having c square plus d square whole square. Okay, this is equals to, now in these two terms in the numerator c square plus d square is common, so c square plus d square, keep this as it is, so we will be having a square plus b square whole divided by c square plus d square whole square. So this part and this single part can be cancelled, so that's it, we get the answer a square plus b square upon c square plus d square. Okay, hence proof. See, in this question we have little bit of calculations, and the calculations are very easy. We have just made use of a single formula, which is this one. Okay, a square plus b square is equals to this. Okay, and this formula we have already studied in our lower classes. So in these set of 4 questions we have understood that how we can make use of the given condition and how we can approach to the question. Okay, so in this way we have seen these 4 questions, and with this we will stop here, and the next set of questions we will see in the next video. Thank you.